let's finally start working on the administration portion of our CMS, and for that we will of course need the login. We have our public portion, now we would like something like the admin web page. However, our website does not understand or doesn't know about the admin, so let's add one public folder named admin, and inside of it we will make one index.html file, index.php file. That will be basically a copy of our public PHP file, and this admin/index.php file will be the entrance point to the administration of our application, the similar way as we have it for the public part. So our admin portion will be sort of like a separate application, if we can call it like that, and it will just share the same database and public content, but it will basically have quite a lot of functionality. For starters, it will be protected, obviously, but it will also have the operations to update the database, to change some data, to add things around, etc. So it will be kind of a separate thing. And a lot of these things here are duplication, and we will come back to that, don't worry. That's why I mentioned several times that refactoring is a very important skill, and we will refactor that and we will remove all those duplications by having some bootstrapping or some configuration, etc. But for now, let's just fix this root path, because we are now one level over, so we need to go one level less. And I will just copy this portion here again. Now, if we go to our admin page, we are sort of getting to the root of the page. However, we now do not want to go to the root, we want to go to a admin dashboard, if you will. So let's work on our routing. And since we have the routing from the database here, for the administration, we don't basically care about pretty URL. It's not important for SEO at all. In fact, we don't want anybody to know about our admin URLs. So what we are going to do here, actually, instead of checking the database for the SEO name of the page, we are actually going to go to our GitHub page, where we can go back in time and go to the lesson where we still didn't have our dynamic controllers, and that is the this singleton, for example. And here in the index we can see the if-else about sections and the actions. This is the way how you would navigate this project, by the way, by going through different tags. And here you can see each lesson that we've done so far. And we can then see how our application has progressed over time. So I will copy this if-else logic here. And instead of this routing, I will put URL-based routing. However, the section, we've changed that to module. So let me just change that quickly. And we don't need the else's for now. We just want to have one, let's call it a dashboard controller. So here we want to use the module path, because that's what we introduced in the previous lesson. And then we are going to have one module that's going to be named dashboard. Now, inside of our dashboard module, we would usually put one folder that's named controllers. However, here we are going to make one sub-level named admin. And then inside of that, we are going to put our admin controllers. Again, we can always refactor if we don't like it. Here we are going to make one dashboard controller, PHP, which will work the similar way as, for example, the pages public controller. So I can just copy that one and refactor it a bit. And instead of all these, I'm just going to echo welcome to the administration, just so that we can see that we are actually hitting this controller. If I would now refresh, there is a lot of problems, of course. And that is because we are hitting this if-else. And we for now don't need anything else. And we will put the default module be named dashboard. And here we're going to include that controller. So from module path, we now need dashboard, admin controller, dashboard controller. Let's see the progress. I'm missing the S here, controllers. And we need to call that dashboard controller, right? So this about controller will be dashboard controller, and we are going to call the default action. In this case, we're just going to show welcome to the administration, and everything is great. However, now everybody can come to our administrator page, and that is not a desired functionality. So we need some sort of login here, some sort of protection of reaching this default method or this default action inside of our dashboard controller. If you remember from the previous lessons, we created one inside of our controller. We are checking if before action exists, and if it does, then we would run it. So let's make one run before action here. And this is sort of like our loop hook, if you will, where we are going to have specific points in the application execution that we can hook things onto, or we can check things onto. So here, this method, run before action, will actually check if we are administrator, if we have the privileges to access this portion. So we can say if, let's just check for one session parameter named is admin. Very creative, I know, but let's keep it simple. So if it is true, then we are going to access this default action. As a matter of fact, all the actions inside of dashboard controller. So we are basically protecting with run before action. We are protecting all of our methods inside of dashboard controller because we are going to call that run before action each time an action is being called. So we are going to return true. However, if we are not logged in, we want to show the login page. And since we don't have one, let's copy one quickly from the Bootstrap. So here in views, we are going to make one admin folder and then one login page, HTML. And from Bootstrap examples, we are going to find, for example, this sign-in page because it fits perfectly. Let's copy the source. Let's just echo this template for now. Let's keep it simple. Let me just remove these integrity and cross-origin checks. And I believe I have to fix the URL as well for the CSS. We don't need favorite icons and we don't need any images. However, rather than just doing the echo from here or dump from here, I will actually create one more action, and that will be called the login action, where we are going to show the login form. So let's just include from the view path the admin login HTML. Of course, we can use our view module and we will come back to that, but for now it's not prepared for administration, and this lesson is about admin portion. Now we don't get anything, and that is because nothing is happening on before action. So if this function this check fails, then we are going to redirect to the login action, right? We can just confirm that by echoing not logged in, then exiting or returning false. And here we can see that we are not logged in, thus we are not allowed to do anything inside the default action. So let's just put one header with the location of admin index PHP, module equals to dashboard, and action equals to login. We can make a separate module for this login functionality, but we don't need to make it more complex than it is. And here we can see that the redirect is actually being done. Now we can see that there are too many redirects, and what is happening is that before running this login action, we are redirecting to the login action, and then before reaching the login action, we are again running this run before action. So we have an infinite loop here, which is what our error message says, that it was redirected too many times. So let's fix that by checking before redirecting if we are on the login page. So you can just quickly check if the action from get and from post as well. And I can put the default as default. We're going to check if that action matches the login string. So if action equals to login, rather than equals, we are going to put if it's not equal, which means that for each and for every other action than login, we are going to do a redirect. If we are on the login, however, nothing is happening. Let's see why in the console. And there's nothing in the console, so I suspect that it is something with this if. So if we are not on the login, that we are redirecting. However, if we are on the login, we need to return true, meaning that we should allow our code to execute. And now we get different things, but at least we are past that initial problem. Now we are including one HTML file that does not exist, and that is because this is not, the login file is actually inside our page module, pardon. So it needs to be here in the view, the official view folder, and this folder needs to be changed as well. So view admin login, right? And now we have the sign in. Now it's missing some CSS. Let's quickly fix that. There is this sign-in CSS, which needs to be fetched from the internet. For now, of course, you will have your resources locally. And now if we try to reach the admin and we are not logged in, we are being redirected to the dashboard login and being presented with the admin login form. And that is exactly what we want to do. Now, when we submit the form, nothing happens, and that is because we are just getting to this action and we don't have any way to handle this one. So what we can do is actually we can make sure first that the form is actually sending data. So the form should have a method post. And since it is post, now we need additional hidden fields that are actually going to contain our actions and sections, because the method post can only submit to the path and it cannot send the parameters to the form like we have here in the question mark module and action. So we have to put these inside of hidden fields with the name action, rather than action, it's the module dashboard with the value dashboard. We need one more for the action and the login. Now this is going to submit our code and reach this dashboard controller here. Here we can either check if the post is being sent, or if we can use an old trick like having one flag here that will be post action, for example, that will have the value to 1, and then we can just check on this post action parameter here. So if post action default to 0 equals to 1, that means that somebody has submitted the form, and then we can process the data here. And for now, let's just say bad login, just so that we can see that we are submitting to the correct place. And of course, if we submit anything here, we are going to get this message bad login. But if we just go to this page, we are not going to see that error message, which means that this if post is actually making another level of control for our controllers. So we can have additional step here, like posting the login form, where we should check if the username and password are correct. So let's get our username and password variables, and they will come from post username. And let's make sure that this username value is actually being sent here. So we want this input to have the name username and the next field to have the name password, so that we can actually use them here inside of our code. Now, to actually check if this username and password match some existing records from the database, we are going to make one authentication service in our source folder that will basically have one method that will be called check login, and it will accept username and password. Now this it will not be an active record here, because it is actually going to use our users active record, which we don't have right now. So let's make one module with the users, where we are going to have one model called user PHP. And this user PHP will extend our active record the similar way as, for example, the router is extending it. So let's just copy something from the router. And of course, the name will be users or user. And the database with the records will be named users. And the fields will be ID, name, username, password, and password hash. And the password hash here is what we're going to talk about. The easiest way to store passwords, for example, for user, is to encrypt them somehow with some method like MD5 or SHA, without using any hash or salt or whatever. However, in these days, those are not secure. Probably were never secure enough. And I will not even go into that you should absolutely never ever store passwords in plain text field, and don't think that this does not apply to your application, because majority of companies out there didn't think that it would apply to them. Companies like Adobe, LinkedIn, eBay, Yahoo, MySpace, etc. If that happened, or more realistically, when that happened, at least we don't want to expose our users' passwords in a raw text format or is in an MD5 format, because a lot of people use passwords, the same passwords for all of their services. And that is why we are going to use the salt hash method here, so that even if we use the same password 2 times, the values stored in database are not going to be identical, which means that decrypting those passwords is almost impossible, at least very impractical. Now, the PHP introduced the password hash function, and you can see in the documentation how to use it. However, in this tutorial, we are going to make password hashing manually, just to illustrate why it is a very good idea to use these provided function and why it's a very bad idea to use one-way encryption like MD5 for storing passwords, because I've seen a lot of people still recommending and using plain MD5 hashing, thinking that it's secure enough, even though PHP provides equally easy function now with password hash and password check, or password verify, sorry. And this is something that, in my opinion, should have been introduced at least 10 years ago. So let's come back to our code first and let's make the database for the users, and then we will continue with the hashing. So I will make these fields inside our database. So I'll make a new table named users with 5 fields, right? 2, 4, 5, with the ID that will be auto increment, and then the name, which will be varchar255, and then the username, password, and password hash, also as varchar fields with 255. Now this 255 is the maximum length, so don't worry, MySQL will not reserve 255 bytes of characters, it will just have that as a top limit. So if we now make this, we can see our table here, and that means that this model now can be used from authentication as an active record here, so that we can check inside the database very easily. Let's just include this newly out and user files inside of our admin index. So this will be module dashboard, oh no, sorry, source auth, and module user models user PHP. And now we can, inside of our check login, start getting the database connection first. We have that already inside of our controller, I think, not the dashboard, but page controller. And then we are going to make one user object from our newly created user object with the database connection passed in. Then we are going to find the user object by field, where the field name is going to be the username, right? And the password is going to be, and the value is going to be the username that we are passing in. Now we are going to check if this actually user find by ID exists. And for now, we can do a lot of clever things to identify inside of our entity if the record has been retrieved, if the find by is being successful by finding it. But for now, we can just see if the values are being set. So the fields that we know exist are the ID, for example. So we can check if our property exists on the user object, and the property that we are interested in is the ID. That way we are going to know if the database have found anything. And here, the old way, the wrong way, we are going to check if user object password is equal to MD5 of the password that's being passed here. Because when we would store our user into the database without hashing, we would just enter something like the username, for example, admin, and the username will be admin. And let's generate one MD5 decryption online. And let's encrypt one MD hash for the string big secret. And it would look like this. So this string big secret will be hashed to look like this. So when you look at the database like this, now if we would naively look at this database, we can think that there is no way you can find out what does this mean from based on this string. However, if we would use some tool like MD5 decrypt, for example, and the way this tool works is that it has a huge database of a lot of hashes inside of it, so you can basically reverse engineer this hash. So if we would give this hash to this website, for example, or if we would use a strong enough computer or a rainbow attack or whatever, brute force attack, we could actually get to this string that matches this hash. And that is one of the problems with MD5, is that each time it generates matching hash for exactly the same string. So if somebody would get hands on our database, that they can easily find majority of these passwords in their original format. So this is as good as plain text stored in the database. So that is why our code here, it would check for this encrypted text that the user has entered now. If the user, for example, would enter here big secret with the username that they have, we would then check if the hash of big secret matches the hash that is in database here. And then we would say all is good, and we would return true here. And we could think that we are safe. However, let's see how MD5 differs from hashing and salting the password. And this would be what I just have shown, the easy or the regular way of having one-way encryption, which means that when we get some input from the form, we can always do the MD5 of it, and we will always get one same and exact string, which is this one here. And then we can store that one in database alongside the username, thinking that we have actually encrypted our password. And then later, if the user would use that same string in the login form here, and they would type this string big secret, we can compare if the MD5 of big secret of this string here matches what is inside the database, in this case this long string here, and then we will just show the success or allow the user to come into our website. However, as we shown, there are a lot of problems with that. First and foremost, the MD5 is relatively easy to guess, of course, up to a certain point. If you would put 50 characters, it would be very difficult to guess it and it would take a lot of time. But guess what? Quantum computers are around the corner, so they can do these sort of things very, very efficiently and in a very short period of time. That is why we at least want to make it a bit harder by using the hash and the salt. And what will happen now is that each time we are going to store our password when we are generating a user, for example, we would have this string, the big secret, and on the side of that we are going to generate one hash that is going to be some random character, also with some sort of salting on the side. And then we are going to store these in two separate fields if we would do that manually. So this will be one field in the database and this will be another field in the database. And then when somebody comes to our website and tries to login by using these strings, the big secret string, we are then going to compare what is being entered inside the form alongside these two fields, the salt and the database hash that are already in the database. And then we are going to do the check on entire that string and see if it matches what we stored inside database. And then we are going to say that this is success. It sounds a bit more complicated than it actually is. What it means is that we are not storing plain hashed values of this entered string. Rather than that, we are storing a salted version or hashed version. That is actually a combination of a string that we know locally. This salt, for example, will be something that is going to be stored inside of our configuration file, for example. And then we can use the combination of password, salt, and hash to also generate the user and the password, but also check if it is correct. And the main advantage here is that this combination over here is never going to be the same, even though we are using the same password, because this hash is randomly generated. So this portion will always be dynamic or always be random. And here we can use the rand function, we can use the date time or whatever we want to, preferably something more secure, a bit difficult to predict. And that's why the two fields that we are storing in database will always be different. I will show you how it works. So let's try and implement this hashed version. However, I first have to say a little disclaimer. This CMS is not 100% secure and it's not bulletproof. And that's not what it's meant to be. The CMS is meant to be an educational project. So I'm focusing on different lessons here so that we can learn new techniques in one practical example. And the security has to be implemented on a much better scale. That's why using the open source project is a very good idea, because there's a lot of people testing it and looking at it and can find some potential problems. So as shown in the presentation, instead of checking on this only password field, we are going to check on the combination of password and some encryption salt and the password hash that's being stored into the database. And that would be the user password hash. And I can think that this is a bit difficult to understand because we are now going in reverse. So I will actually now make one function that will change this password programmatically so that we can see how it is generated, and then it will be much clearer how it works. Let's first make this encryption salt somewhere in the index, which will later be moved to the config file. So here inside of the index, we are going to define one constant named encryption salt. And for now, it will be just a gibberish of some random characters, because remember, we are going to use the PHP integrated function, which will create salt and hash for us. So we don't have to deal with it at all. But this is something that we are going to need because we are going to make and check our passwords based on this salt string. So if I would make one function here named change user password, it will accept the user object because we have the active record, and it will accept the new password. And then we're going to make our hash out of some random string. For example, let's use the date, I don't know, with the year, month, date, hour, and second. You can use the timestamp or whatever, it doesn't matter. And let's also complicate it with some secret string, 1, 2, 3, whatever. And then we are going to make our hash as, for example, MD5 out of this temporary string to make it even more difficult to guess. And now we are going to make our hashed password following the same logic as we are doing here, or the same as we shown inside of our PowerPoint presentation. So it will actually be a MD5 of this entire string. And instead of this from the database, we are going to use this newly created hash. The password is the new password. And this hash password is something that we're going to store with the user inside the user database. So the user password will be this hashed password. However, we are going to need this hash because we know the encryption salt and we know the new password now. We are going to store this password hash inside the database as well. And then here, when we check for the login, we can use that same string from the database and we can check if what user has entered matches what is being stored inside of the database. Now we are going to return the user here. Of course, there are multiple ways to change the password without returning and passing by reference or not passing it at all. We should basically just generate a new password and then return it. It's not that serious for now. However, in order to call this change user password, we would need to have entire administration portion of our application, which is something we are yet to build. We don't have today. So I will just quickly make one index copy, and this file does not need pretty much anything besides the database connection, the entity, authentication, and the user. And there is no navigation from here, but it will need one user object equals to new user, which also needs the database. So let's create database connection. We can copy that, of course, from the authentication. I hope that you've noticed that I am copying the same thing a lot, and that should be avoided. And this user needs database, as we discussed. And this user also needs to be found from the database so that we can actually manipulate it. So let's find it by username, and the value we can hard code it because we already know that there is one user in database called with the username admin, right? And then we are going to pass this username to our authentication object, to the method change user password with username and the new password with the value top secret. And let's just dump this user to see what's going on. Actually, it is returning the user, right? If I would now to call this index temp, we're getting some problems. And what is now going on, there are no values fetched from the database. However, we can just check if the database data is being set and then use this set values. So it means that if there is no data from database, nothing will be set. And now we have another problem with the router module and action. Let's remove that one as well. And that is basically because we have the index_1 rather than index temp. Now, if we would refresh, we can actually see our password and our password hash here being generated. And if I would refresh this, you can see that this value is changing each and every time I refresh. Now it's changing every second because I'm using the date and with the seconds as the hash. But if we would to use simple MD5 here for the new password, for example, if I would just comment this one and set the user object password to the hash to the MD5 of this password string, we can see, it should be a property, we can see that no matter how many times I refresh, the same string is being generated here because MD5 does one-way hashing and it will always generate the same string, the one that we also generated with this file here by having the big secret string or top secret or whatever. And we can even validate that by using this top secret string and encrypt it on some other website. It will always give us exactly the same hash like this one here. However, with our salting and hashing method, even if we would try to run this password string inside of some decryption tool like this MD5 encryptor. There are no results found, and even if it would find a result, the result will also be this entire hash of another hash with some salt, with some password in it. So it will be very, very difficult to go all the steps back to get your old passwords back. However, if you have used the internet for some time now, you might have come across some old forums that will actually send you your old password on email in case you forgot it, and that forum is a bad apple when it comes to security. Every decent application will now just send you a link to generate a new password, because the way the passwords should be stored is in a such way that nobody, even the people working with the database, should know which passwords are users using. And now, since we have this user with the new password here, we can actually enter these values inside the database. So this password should be this string here, and this password hash should go into the password hash field, of course. And let's get back to our login. This index.temp file should be deleted. I will leave it in the source so that you can check it out. But remember to delete it, because it will generate the new password each time you run it, and we don't want that in the open internet. So if I would here write some wrong password, 123, or the wrong email in this case, let's fix it so that it's not an email field. So the type should be text. Now we are getting the bad login again. And if I would enter the correct password, so admin top secret, I'm still getting bad login. Now let's see why is that. Let's debug our application. Now let's see if we get the user from the database. And we don't even get to that check because we are not even implementing this authentication. So let's implement that one quickly. So we are going to check if the authentication check login on this username and password that we got from the post is returning us the true. We can just say that all is good. And we can actually set this session parameter that we are checking is admin. So if this admin is here authenticated, we can say that is admin equals to 1 now, so that next time we are passing this before action with all parameters properly. And then we are just going to redirect to the dashboard the same way we are doing here. And our dashboard is in the admin here. And we might as well exit here. Now let's try this one again. And I see that we have undefined variable user, which is not what we should check on. We should check on user object. Now let's try that one more time. And we are back to bad login. Now what I think happened here is that somehow I've entered the wrong values inside the database. So let me just double check that, and let's generate a new password and put it inside database just to double check that. So let me check again with the new hashes and new passwords. So the password is top secret. Yes, and if I sign in, I am welcome to the administration, which means that this hash check that we have here matches what we used when we created the hash in the database in the first place. So we are now all good and we are welcome to the administration. If I would refresh several times, I will still be logged in, and that is because we have this session parameter here inside of the dashboard controller named is admin, right? If I would to remove the session now, if I would clear all site data, which would basically means that I got a new session or new browser. If I would come to the administration, I will be sent to the login. And I see that there are a lot of you who are following this tutorial, coding along, and I wanted to introduce something new for you guys and girls, a homework. Yay! You see, when you are starting working as a developer somewhere, you will get some tasks to do on your own. And this is pretty much what this homework is, a task from a real-life project. So try to do it if you're really serious about learning. And if you're already working somewhere, you know that if you don't use it, you will lose it. So practice, do your homework. So your task here is to create a password validation. If you notice, we have only checked here if the username and the password are correct. And your task is to somewhere here check the length of the password. So the password should have a minimum of 6 and maximum of, let's say, 20 characters. And the password should have at least one special character. You should do this in the object-oriented way, as that's what we are learning here. So as a hint, try to think of two types of classes. One type that will be the validator itself, and one type for all the rules that it will validate against. and you can just dump that there is an error, or you can try to display the error message to the user. And if you would like to share the solution, or if you get stuck, publish your code on the GitHub or to the gists, and ask me anything in the comments, and I will try to answer and to help you get to the goal. And in the next video I will make one version of validation, and we will discuss something new as well. Again, this is a typical junior developer task, so I would really advise you to try and do it on your own before you watch the next video if you're serious about working as a developer. And as mentioned before, PHP includes all of this for us inside the functions password hash and password verify. So let's see how it works. And here on this PHP website, we have one graph showing how these passwords, how this hash is being generated. The PHP function, included PHP function, is a bit different in a sense that it is way more powerful and much more tested. Faster, it includes several algorithms, it can be configured for different servers, but it works in a similar way, except that it stores the salt with the hash in a similar string, the similar way as we did with two fields. You can see that they are storing the salt as a part of the string and the hashed password itself as another part of the string. They're also saving the algorithm and the algorithm options. For example, the cost of it, how long and how difficult it should be, etc. And they're putting everything this into one field so that when we store it inside our database, we can just store one text value rather than several as we had in our example. And this is much more secure, and it will also generate the salt for you. So it only makes sense to use this function, right? But I think it is very cool at least to know how it actually works and why it is so much secure. So let's refactor our authentication object, where we would basically remove all this salting and things that are related to our encryption. And we are just going to use, instead of this hashing that we are doing on our own, let's make the use of password hash function, which will accept our new password. And it will accept the algorithm. In our case, we will just use the constant as on the PHP page. That will use our password default algorithm, which might as well change in the new versions, or it could be different on the server than on your local PC. It doesn't matter as long as it's consistent. And this password hash will basically make our password with the hash included. So we don't even need this password hash field. So we can just call it and set it like this. I will actually leave this code commented for you so that you can use it if you are coding along, so you can compare it. And then if we would call our temporarily admin file again, let me just clear the database so that it doesn't confuse us. Now inside our administration, we can actually see this string representation the similar way that they have presented it on the php.net website, where it has some parameters, some salt, some hash, etc. And we don't basically have to think about it. What we need to use beside the password hash is the password verify. That is going to take the password that the user is submitting. In our case, this will be inside of the check login. So instead of this line, we are going to check if password verify, where the new password and the password from the database would return true. And now let's just update our database before we forget with this string. Now if I would to try to log in with the admin user and the top secret is a password, we are getting bad login again. I really don't know why. Oh, that is because I'm using the password hash here. I should use only the password. So if I would refresh again, we are being welcome to administration, which means that it's working. So it's that easy to use it with password verify and password hash. So there is no reason to use MD5 encrypted passwords, or rather hashed passwords, because MD5 is not encryption. Now take a break from this video, do your homework, and I will see you in the next video. Bye.